Hi everyone. So I'll begin in a few minutes and happy Holi to everybody. Good to see people still joining, even though it's Holi. So if in the meantime, we'll take just 2-3 minutes to start because some people join in a few minutes after 6. So in the meantime, if you have any questions from this week, last week, any of the previous weeks, you can just post it in the chat or you can unmute yourself and speak. So we'll just begin in 2-3 minutes, just giving time for people to join in. For those who have just joined in, if you have any questions, please just post it in the chat box or you can just unmute yourself and let me know. Okay, so I think we can get started. So nobody's posted anything, so I'm guessing that nobody has a question. So let me just connect to my iPad. Just give me a moment, please. So today we will be discussing mostly cost minimization and some parts on opportunity cost, implicit costs, all of that. So any questions in the theory, like, before I come to the numericals and the questions, if you have any questions on the theory, please let me know. Okay, so let's move to the questions then. Just give me a moment. Okay, this is where. Question 9 and 10 of assignment 8. Okay, 1 minute. Let me just open assignment 8. Question 9 and 10. Okay, this is from the NPTEL, right? Comprehension problem. Suppose a jet produces peaches and his output is given by L to the power half, T to the power half. This question? Okay, let me just go through this. Okay. Blah, blah, blah. So, what is exactly troubling you in this question? In question number, this is what? Question number 9. So, what they're asking for is, I think, like the production possibility frontier, right? T in terms of L. So, question 9 is, I think, okay, let me just solve it on paper itself. Hang on. Okay, question 9, then 10 is in the short run, Ajay cannot vary the amount of land he uses. What will happen to the marginal product of labor with increase in units of labor used? Okay. All right. So the 10th question is actually more of a conceptual question. So in the 10th question, this is basically just a short run, you know, description. If in the short run you can vary only one input, say suppose there are two inputs, one is land, which you can say is equivalent to capital, and the second is labor. So capital is not changing, only labor is changing. We know that with every additional unit of labor, the marginal product of labor basically becomes okay. So the marginal product of labor basically is implies diminishing marginal product of labor implies that with every additional unit of labor, the productivity is decreasing, right? So if for one unit of labor you are able to produce, say, just arbitrarily I'm saying, yes, you say suppose you're able to produce 5 units of output, then for 2 units of labor you're able to produce, say, 4 units of output. For 3 units of labor you're able to produce, say, 2 units of output, additional units of output, sorry. So then that means that for every additional unit of labor, your additional quantity of output produced is decreasing. Okay, let me do that also on the graph itself. Okay, let me just do these two questions first. Any other question anybody has from the previous week? Hang on. 1 minute. This is something is wrong. Yeah. Any other question anybody else has? If not, then I'll just solve this one. And oh wait, let me just solve it separately. This one. Okay, so let's first do week 8 assignment. You're asking question number 7. Okay, let me see what is question number 7. So decreasing marginal product for factor 1. So this is basically something you'll need to calculate, right? You can, what is this? This is Cobb-Douglas function, right? So you're given the production function, you have the, two factors, x1 and x2, power is a and b. In question 7, they're asking, is there decreasing marginal product for factor 1? For decreasing, meaning first you calculate marginal product for factor 1. If you understand what it means, marginal product of factor 1, right? It means that, like how we were talking about marginal product of labor or capital, instead of that, they're just saying marginal product of factor 1 or factor 2 is the same thing. So what condition is given to you is, it's just that for positive values of a, b, and c, right? This is a, b, and c in question number 7. Again, it is just given that values of a, b, and c are positive. What you want to know is for what condition the marginal product for factor 1 is decreasing. So you just calculate the marginal product for factor 1, and then you find out, you can take a first order derivative of it, I guess, and then you can see if it is decreasing or increasing and what values give you that. Okay, I'll come to question 7. Let me just explain this part to you first, question 9 and 10. Okay, so question 9 is fairly straightforward. Okay, question 9 is given as f of L comma t is equal to L to the power half t to the power half, to the power half, right? Now you're given that f of L comma t means what? This is equal to output. That is what output function, production function gives you. So if he is producing 4 bushels of peach, means Q is equal to 4. So 4 is equal to, you can write this as under root of L comma L into T. It's the same thing, right? You take square on both sides, 16 is equal to L into T. And from there, you can just simplify this to 16 over L, which is your answer. So this is just a mathematical simplification of the same thing which you're given. Okay, this is question number 9. Is it simple? Is it clear? Okay, question 10 is not numerical, but what they're asking is in the short run, he cannot vary. Say, suppose you have some production function of say L comma K, assume K is land, and you know, I'm not giving you a value for this. This is some production function. Okay, I'm putting it as equal to Q just for the sake of simplicity. So he cannot vary land. So K bar is fixed in short run, right? What will happen to the marginal product of labor if with increase in units of labor produced? Used. This is L, this is Q. Okay, so when we take marginal product of labor, what we mean is dq by dl. You can use small q, big Q, whichever way you like it. Or you can say delta q by delta l. It's a simplification of the same thing. So it just means that it is becoming something like this, if I have to represent it graphically. Which means, say, suppose I draw a chart like this for L and Q. L is 1, so Q is 5, L is 2, Q is say 9, L is 3, Q is say 12, L is 4, Q is say 14. Okay, so for here, let me use some other color. The difference between this and this is 4, additional 4 units. This and this is 3. This and this is 2. Okay, this side, of course, there is only 1, 1, 1. That is what we mean by diminishing marginal product of labor. Let me see what you're saying. Okay, so are you understanding what this means? That with every additional, when you're increasing Q this side, okay, if you want to draw it graphically, and so on and so forth, you can go on drawing it graphically like this. You can see that with every change, wait a minute, I've drawn it the other way around. Sorry. This will be the, I've taken this as Q. This will not be Q. Yeah, I've drawn it wrong. Let me just redraw this whole thing. Because if I mean, I could have just drawn the same thing with vertical axis as marginal product of labor, but then it wouldn't be clear to you. So say suppose it's like this, okay? Again, same thing. So you can see that, you know, with every additional unit, increase in Q is decreasing. That's what we mean by diminishing marginal product of labor. And since we are only talking about one input, right? Because there is no role played by the other input. They're saying that in the short run, land is fixed. So it means that marginal product of labor is going to go on becoming flatter. They're talking about what will happen to the marginal product of labor. Actually, this question should have been framed slightly better. because it's like they're talking about a curve, but they've not mentioned that what will happen to the curve of marginal product of labor. Like, yeah, I mean, it's not wrong, but it just could have been framed a little bit better. Either way, so you understand, it will go on becoming flatter and flatter. Is this clear? Okay, all right. So let's go to, I will come back to question 7. We will do something, I think we'll do something similar in one of the questions today. So I think that will answer your other question also, question 7, where you're talking about marginal product of factor 1. So if not, I will discuss it at the end of the class. Okay, so let me move on and share today's slides. Right. Okay, so coming to cost. So this week we will be discussing mostly cost and of course production, but production in the context of cost minimization and cost functions. So this is the first question, which is just a very simple conceptual question. Which do you think? Which statements do you think are true? You can take a minute to think about it. These are questions about total cost, average fixed cost. You can post your answers in the chat. There can be more than one correct statements. Any takers? Nobody? Okay. Okay, somebody is saying, all right, I have noted 2 answers. Anybody else? I'm giving you a few seconds to think. All right, now let's go to a question. So what is average total cost basically? Okay, all right. Okay, I've seen most of your answers, I think. Let me just open the question again for myself. Okay, so now first question is total cost and average. So first of all, what is average total cost? You can see my screen, right? Yeah. So average total cost is nothing but total cost by quantity. That's how we take the average, which means that total cost, or you can say TC, is nothing but average total cost into quantity. So the first option is correct. Total cost is the product of average total cost and the quantity produced. I don't know why nobody got this option right. Somehow all of you missed the first option, which is the most obvious option. Okay, then the next option was total cost is the sum of each short run marginal cost of all units produced. And that's not true. I know that I think maybe all of you have, not done it. Have all of you watched all the videos till the end? for week 9, that is. Okay, one person has said yes. So that's the hopefully the thing. But you have watched most of the videos. Okay, 2 people, great. So the short-term marginal costs do not sum up to give you the total cost. That is not how the maths works out. Okay, so that is obviously not going to be true. So the second option is not correct. The third option is average total cost is the sum of what? So total cost itself is the sum of variable cost plus fixed cost. I'm using short forms, but I hope that's okay. And this is fixed. Okay, so total cost is equal to variable cost. Now, if you divide the whole thing by Q, you get what? TC by Q is equal to VC by Q is plus FC by Q. This is what? Average total cost is equal to average variable cost plus average fixed cost. Isn't that so? So that means which option is this? Third? Yes, so this is the third option, and C is correct basically. This is option C. Okay, now the next option was average fixed cost is always declining with quantity produced in the short run. So here you have fixed cost is fixed, right? So we just took this total cost is equal to variable cost plus fixed cost. Now variable cost is varying with Q. When we say varying, we don't necessarily mean varying with time. It may be varying with time, may not be varying with time. This is one thing which is kind of assumed to be very obvious, but sometimes it's not that obvious. When we say varying with, we mean varying with Q. So this is a function of Q. Whereas fixed cost is just a fixed number. For example, you can have a cost function given by 4Q square plus 2Q plus 10, something like this, right? This is the total cost function. So in this is your variable cost and this is your fixed cost. Okay. Now, if we take averages, then what happens to average total cost? Say, suppose we take it in the same function, this function, let's say this is a function of Q. Then, C by Q is given by 4Q plus 2 plus 10 by Q. Now, let me put this in some other color. And this is your average variable cost. And this is your average fixed cost, right? Why? Because, oh, I don't know why this scrolls on its own. This part was your variable cost, and this 10 was your fixed cost, right? You have to look at the original cost function to decide which one is variable cost and which one is fixed cost. 10 is a fixed number, so it's a fixed cost. Now, after you divide the whole thing by Q, you get this part as the variable cost, the pink bracket, this thing, and the remaining part, this part, is the average fixed cost. Now you can see that because the number is fixed, right? 10 is fixed. So if you keep on increasing Q, average fixed cost will go on decreasing, which means that average fixed cost is always decreasing with increase in quantity produced. Let me see what was the exact wording. Yeah, average fixed cost is always declining with quantity produced in short run. We're talking about short run here. So let's put this as D. This is option D. So average fixed cost is declining with Q, increase in Q or Q, whichever way you want to say. I mean, this variable cost function or even the whole cost function itself can be anything, right? But the fixed cost will always be fixed. Like it'll be some number. I've taken 10, it can be 5, 20,000, 10,000, whatever, but it's a fixed number. If you divide a fixed number by quantity, obviously it's going to keep on decreasing with increase in Q. Okay, and what was the last option? Total cost is always declining with quantity produced. So this may not always be true, right? This was the total cost function. Sorry, this is the total average cost. Yeah, this is your total cost function, right? This is total cost. As you can see, this is a quadratic function, 4q square plus 2q plus 10. And q is obviously positive quantity here. So for example, total cost is, say suppose what I took 4q square. This is the positive part of a parabola, right? Because q is greater than 0. It's sort of understood, but q is greater than 0. Just give me a moment, there's somebody at my door. I'll just be back in a minute. Yeah, sorry about that. So as you can see, this is a continuously increasing or a convex function cost, this function which I've given you. Now, of course, cost can come in many different forms, but it's very common to find a cost function of this type. It may not necessarily be a quadratic function, it could be a linear function, could be some other function, but it's not at all true that the total cost will always be decreasing with increase in quantity. It may be decreasing or it may be increasing. So there are many situations where costs actually increase with increase in quantity. So in specialized cases, of course, there can be cases where costs are decreasing with increase in quantity, but I mean, it usually won't happen because, you know, it may be that your marginal cost is decreasing, but the total cost, which is what we're talking about here, is very less likely to be decreasing with increase in quantity. So the last option, which is total cost, is always declining with quantity produced, is not correct. So I think that sort of covers all the options. So any doubts? Can I move on? Okay, so let's go to the next question. So I have not given any options in this. It's a slightly longish question, but you can just type in your answer for this. It's a question on opportunity costs and accounting costs and economic costs. So I think I've already given you a clue by saying that, but I'll let you calculate it first and then just write the answer for both economic cost and accounting costs. I'll just give you 2 minutes to solve this. Nobody wants to answer? It's not very difficult. Okay, two people have answered. Anybody else? Okay, I just want to check if anybody else also wants to answer. Okay, I think one more person has answered. I'm just giving one more minute. And I just want, yeah, I'll answer that. Whatever you mentioned on chat, I'll answer that. Okay, I think we're out of time. So let's see. What we have is that, earlier Joe was earning 50K per year in a regular programming job. Okay. So here we're taking his salary as his profit, right? As in he was earning that much amount. And initially he was also owning uh, a a house, or what was it, apartment or something. He owned a building, it just says building, and he was getting some rent from it, which is 24K. So let me just annotate here itself. So this was what he was getting earlier. This is what he was getting earlier. Okay. Now, in his first year of business, he has paid salary to himself 40K, and his other expenses are 25K. But salary he has paid to himself, and this is negative. So what you can do is, an accounting cost, you will take what 40 is, um, wait, 40K is not going to be included in cost, because if you're talking from the whole point of how much he's earning, then 40K is what he's earning here, right? So you have only 25,000 as the cost. In economic cost, you have basically 25K is already there, plus what is the implicit cost? 50K, which he was earning before, plus 24K, which he was earning before. So you can calculate how much is this, 45 plus 50. You can see this is 95. Problem? Is this making sense? Because we
Ma'am,
are
I have a
taking,
small doubt in this.
yeah.
Ma'am, when we talk about cost, even if he's like he's paying salary to himself, isn't it that cost incurred to him, ma'am?
Yeah, so that is basically a difference. I mean, you can look at it both ways, but then you have to look at it both ways in both the scenarios. When we're talking about earlier, where he was earning a salary, we were taking this as his income, right? 50K was his income. So here also, he will take 40K as his income because he's taking that as a salary to himself.
Ma'am, but isn't when we're talking about accounting cost, isn't it the cost to the business, ma'am? Or is it only the cost incurred to him
So
as an
the in
individual?
this case, he has basically, it is only a one person business. It is not exactly explained that, the difference between a business and an individual earning right now. At least that is how it is. So I will check
Mama,
this out. At least as per me, I think this is how it should be, because 40K is what he's earning from the business, because it is something which is mentioned as salary paid to himself, right? You can't also take that as a cost and a profit both.
ma'am, if that be the case, ma'am, when we talk
Yeah,
about economic cost now, ma'am, in that
yeah,
we have taken as rent, loss of rent, that is understood, that is implicit cost. Then the loss of his salary, also opportunity cost, that is understood. Now
right.
25K is the additional business. That means it makes a total of 99K. But ma'am, in this case,
Oh, sorry,
isn't there
99.
also,
Yeah, I've put as 94 by mistake.
that
Yeah,
is
what
just
were you
fine, ma'am.
saying? Yeah.
Ma'am, but then in this case, shouldn't we reduce 40K from it then? Because he's already earned 40K on this.
So, no, I'm talking about cost, right? So we are not talking about earning. You can't mix benefit and cost.
Ma'am, because when we're talking about accounting cost also, we didn't take into account his 40K as earning.
Yes, so that's the
Now,
same thing we are doing in economic cost also, right? Because we are taking 40K as benefit, not as cost. So in economic
Roger, ma'am.
cost, or whether it is accounting cost or economic cost, either you can consider something as a benefit or you can consider it as a cost. In this case, we are taking the salary as a benefit in both the cases, previous salary as well as current salary. So in this case, we are taking 40K salary that he's drawing as a benefit, not a cost, right? So that is why you will get it like this.
Roger, ma'am.
Okay.
Thank you.
All right. So next, a similar question. Maybe this will help clear things up a little bit more. I will again give you 2 minutes to just read the question properly. So read it properly, because this is slightly a little bit more conceptually intense than the previous one. So in this case, there is no confusion about salary here, but here what you will see is that there is a change in what options say a firm has after they buy some capital. So I'll just mute myself for 2 minutes, just read the question. There's not much to calculate, but just read it and then tell me what you think are the correct options. Okay, only two people have answered. Hmm. Anybody else wants to attempt? It doesn't matter whether you have it all right or not, at least in this particular class, because nobody is grading you in this class. It's only for your own practice and your conceptual understanding. So, okay, one more person has answered. That is good. Okay, anyone else wants to try? No? All right. So let's see what it's saying. So the firm has bought a forklift for $25,000. Okay, in 1 year, they find that they can still sell the forklift for the same amount, $25,000. Let's assume there is no depreciation. And now, after 2 years, the firm finds that they can sell it only for $10,000. And 3 years later, they find that they cannot sell the forklift at all. So now, leaving the options aside, um, in the first year, after the first year, what is the sales value of the forklift? It's 25,000, right? So they bought it for 25,000, and they find that we're not saying that they have sold it. We're saying that they find that they can sell it for $25,000 if they want, which means that they are foregoing that much money if they continue to keep the forklift and not sell it. So that becomes its opportunity cost, right? So in 1 year, if they don't sell the forklift and if they keep the forklift, then they are foregoing $25,000, which means that $25,000 is the opportunity cost of the forklift. So that means, let me annotate here, this option is correct, right? Now, after 1 year, do you think that $25,000 will also be the sunk cost? Is that possible?
Ma'am, in case they sell it, it won't be the sunk cost.
It's not about whether they sell it or they don't sell it. It's about whether it can be sold or it can't be sold. Right? Whether it's, see, this is a subtle point which you have to understand. Sunk cost is not decided based on what you do, it is based on what options you have. Right? So the example I think which Professor Vimal gave in the class, and it's a very common example. Like, say, suppose after 5 years of studying medicine, a doctor chooses a person who has finished their MBBS, they decide to not become a doctor, right? So at that point, whether when he continues in that path or he does not continue in that path, or whatever career choices he makes, whether he does an MBA or he does something else, that amount he has paid for doing his MBBS is irrecoverable. There's nothing you can do about it. There is no way you can recover that amount. You can only do something else going forward. You cannot go backward and recover that amount you have already spent, already invested into the degree, right? So similarly, in this kind of a scenario, that is why this is not a question from a book exactly. I made up this question, but I mean, it's a similar question is there in Perloff. You can look at it if you want. It's a solved thing. But the point is that it's not about whether you actually sell something or not, but whether you have the option of selling it or not. So if you bought some machinery or if you bought some land, say suppose you bought some land, right? You bought some land in maybe some area, and there is some problem, some natural calamity, something, and you cannot sell that land anymore in the market. There is no market for it. Nobody, there are no buyers at all in the market. Then it becomes a sunk cost. If you have an option of selling that land and you get an amount, say some amount for that particular land, you can get some amount for that particular land and you choose to not sell it, then it is an opportunity cost. But if there is no option for it, there is no other alternative, you don't have any alternative, then it is a sunk cost. So in this case, 1 year later, it is not a sunk cost, because 1 year later they can still sell the forklift, right? They can sell it for 25K. But it is not that I have finished off that money. They can still, if they want, they can sell the forklift and earn 25K. So it's not a sunk cost after 1 year. 2 years later, what happens? That they can sell the forklift for $10,000. So after 2 years, they can recover only $10,000 from it if they sell it. Remaining amount is what? It's lost. You cannot recover the remaining 15K. So 15K is the sunk cost. So this, what happened? So C is correct. That after 2 years, because you can recover only 10K, the remaining 15K is lost forever. You cannot recover it at least from that forklift in any way. Now, 3 years later, what happens? 3 years later, you cannot sell the forklift at all. So that means the whole thing is gone, right? The 25K, the whole money you invested, everything is lost. Nothing can be done. Now you're stuck with the forklift, whether you like it or not, whether you leave it in the scrapyard or you donate it to somebody or you just leave it lying in your warehouse, whatever else you do, you cannot sell it. You cannot make any money for it. Assume you cannot even sell it for scrap because that's what's given. You cannot sell it. So that whole thing is gone. So that means that is its sunk cost. It's not the implicit cost. That is what I wanted to clarify. If you were able to sell it and you decide to not sell it, then it is the implicit cost. Implicit cost is opportunity cost. But because you cannot sell it at all, that is the sunk cost. Now, let me see how many of you got this right. Yeah, I think one person got it right, all the options right. So that's good, great. Okay, so let's move to the next question. Let me give you a few minutes to solve this. We will, I mean, I can solve it in a little bit more detail, but I just want you to attempt it first. So let me know. Be careful, it says read the question fully. Yeah. Okay. Anybody else? Only one person has answered. Anyone else wants to attempt? No, it's not a very difficult question actually. Okay, so let's go to the basics. Okay, all right, two people have answered. Let's go to the basics. What we know is that marginal product of labor is equal to delta Q by delta L, or you can say dQ by dL. Okay. Now, marginal cost is what? Marginal cost is equal to sorry. Marginal cost is equal to what? W into delta L by delta Q. This is the total amount of cost for um, when talking about marginal, so you can say per unit of, for all the delta L units of labor, this is the cost, and you want to take marginal, so that's why you have delta Q here. Okay, is that making sense? Yes. What is the, for, okay, let me split it out. For delta L units of labor, cost is wage into delta L, right? Wage is per unit, delta L is the unit. Now, if you want to take marginal cost, I'm taking it as delta, you can take it as DL also. It's just easier to understand usually in delta L terms, but if you want, we can just take it as DL also. Now, marginal cost means what? Per unit quantity, not per unit labor, right? Marginal cost is W delta L upon delta Q, isn't it? That becomes W upon delta Q upon delta L. You can write it in this way also. But what did we just say? MPL is delta Q by delta L. So this is W upon MPL. So your answer is marginal cost is equal to W upon MPL. Is this clear? Any doubts? If you want, we can write it in the, in the differential, using the differential notation also, but it is basically the same thing. It's just a bit easier to process if you write in delta terms. Marginal cost means what? The cost for one additional unit of output, right? So if you're varying the labor, because we are saying it is in short run anyway, and we are anyway, marginal means like you're taking it in terms of one variable first. So if you vary one, instead of taking one unit, let's say we are varying labor by delta L units, then the increase in cost is W into delta L, and we are taking the marginal cost, so means we will divide it by the increase in output, which is delta Q. So you get this, if you simplify it, you get it like this. Now, if this were not short run, if this were long run, then this would also come out to be equal to R by MPK. But because it is given that it is short run, this is not going to happen because capital is fixed. So there is no MPK basically. Is this making sense? So this is it. This is the answer. Let's go back to the question. So B is the answer, right? This is the answer. I've given the other two options, last two options, just to confuse you. In the long, sorry, what is the message? In the long run, is plus R by MPK. Yes, so that's what I said. In the long run, it will be equal to W by MPL and R by MPK. But because we are not taking it as long run, we're taking it as it's given in the question that it is only short run. In the short run, you will only have marginal product of labor. You will not have marginal product of capital because there is no variation in capital at all. Uh, no. So in the long run, you will typically have W by MPL is equal to R by MPK, not plus, and both will be equal to marginal cost. You can check it out. You can see the whole MRTS calculation, and it comes out to be something like that. If you're not convinced, you can solve it and see. Okay. Are you convinced? I mean, you will have to solve it to confirm it. I mean, I can tell you that it is like this, but if you want to be convinced about it, it is better if you solve it and see. Or you can refer to the book, it's there in the book. It's solved, I think, in the book, if I'm not mistaken. So when you're taking marginal, you know, values, marginal product of labor or capital, or whichever factor you may be considering, you will weigh. It means you're taking variation only in that particular factor. You getting me? What you're saying is it's not true for the marginal values. What you are saying is AW by MPL plus R by MPK, that is not going to hold. You are simplifying it based on the cost function you sometimes get. But that is the cost function, not the marginal cost function. In the marginal cost function, you have to differentiate it with one factor and then the next factor. Did you get the difference? Okay, so let me go to the next question. Let me pause it here. Okay, good. So let me pause it here. I'll give you 10 minutes to solve this. Is not a very difficult question, but in this question, I can try and answer your question also. We will go over that. And I will just take a 10-minute break. I just need to have some tea. And then I'll come back and we will solve this together. In the meantime, if you have solved it, please post your answer in the chat box. I will answer. I mean, I just want to see how many people have got the hang of it so far. Okay, I'll be back in 10 minutes. Okay, so I think only one person has answered so far. Let's see, what have we got? So let's work out the problem. This is question 5, right? 5. Okay, so we are given the production function root k plus root L, and we are given the values of R is equal to 5, W is equal to 50, and we are given that the firm wants to produce Q is equal to 110. And we want to know what is the um, value of labor if the firm is going to minimize its costs. So although everywhere it has been mentioned that the firm is minimizing cost, but in general, in everywhere in production economics, that is sort of like given. A firm will always want to minimize its cost unless they explicitly give some other objective. So anyway, now what will we do? First of all, let's calculate the MRTS, right? Marginal rate of technical substitution. We know that MRTS is equal to MPL by MPK. Is that correct? Is everyone convinced with this? I hope I don't need to derive this. This is basically what we studied in the class. It's there in the lecture videos. So if you have doubts about this, I suggest you go back to the lecture videos. And if you're still not convinced about it, we can discuss it again. But for now, let's assume that everybody agrees that MRTS is equal to MPL by MPK. So just for my understanding, is there anyone who actually does not agree with this, who's not convinced about this? Problem with this? No issues with this? Okay, great. So let's go ahead and calculate the values of MPL. So MPL means what? Del Q by del L, partial derivative of quantity with respect to labor. So we get this as 2 under root L. Similarly, if we take MPK, okay, yeah, this is seeing what you were saying. So then we know MPL and MPK in terms of L and K. Let's find out MRTS is equal to again MPL by MPK. MPL is 1 by 2 root L and MPK is 1 by 2 root K. So this comes out to be is equal to okay. So far so good. Oops, sorry. Just trying to write it better and it. Yeah. So far so far so good. Okay, now we know another identity which always holds true, which is that MRTS is equal to W by R. This also we know. In our case, we are given W and we are given R. So what we need to do is, this also is discussed in the class, and I was just explaining it that, how this is the value you usually arrive at. And this is equal to MPL by MP K, right? So we know the expression for MRTS in terms of MPL and MPK, and we know W and R. So what we do is we do K by L under root is equal to W by R, and we have the values 50 and 5. So you have 50 by 5 is equal to 10. Now you take square on both sides. K is equal to 100L. Yes? Any problems? Hopefully not. So now we have an expression for k in terms of L, right? And we know the original production function. Let's call this equation 1 and let's call this equation 2. So then from 1 and 2, we have q is equal to root 100 L plus root L, which is equal to q is given as 110, right? Yeah. So very convenient value of q you have, which is 110. So then from here it is not a very it's not a very complicated simplification. What you have is 110 is equal to, it's just checking if anybody is saying anything. So what you have is 110 is equal to 11 root L, which gives, you can divide both sides, gives L is equal to 100. Okay, any problems? No problems? We can move forward. Yes. See, it's not a very complicated calculation here. Let me break this up further if you want. This means 10 root L plus root L is equal to 11 root L, right? Q is 110 is equal to 11 root L implies L is equal to 100. Now from here, it's not asked in the question, but if it is asked in the question, you can calculate the value of K also, which is 100 into 100. It's not asked in the question, but basically, I mean, I'm just showing you how to solve this type of a question in completion. You're asking why we didn't use the equation WL plus RK equal to Q. You can use that also, but basically when we do this, when we say MRTS is equal to W by R is equal to MPL by MPK, we are, in a way, we are using that equation itself, right? That equation is where you get this, from. So this is one method of doing this. If you want, you can do it by the other method also, where you take the production function and you take the cost function and then you replace from one to the other using the values of R and W, but you will basically arrive at the same result. I'm just showing you a different method of doing the same thing. It's usually a shorter method because it's generally a bit simpler to take the ratio of MPL and MPK and W and R rather than taking the value of K from that cost equation and substituting it back. See, this identity you get from cost minimization only. You won't get this always. So in this case, we have automatically assumed that cost is equal to W L in plus R into K. So this expression is used in deriving this. Yes, you can try and solve it in, using this whole method also, where you take the cost function and then you take the value of one from the other. So you can take this and you can, you know, substitute the values of W and R and you can solve in terms of L and K, and you take in the production function, you take, or the other way around, you take the production function and instead of K, you substitute. Okay, let me just solve it here. So what you can do is, let me solve it below. It's going to get too messy otherwise. Okay. So you are given Q is equal to root K plus root L. I'm not solving it in entirety, but I'm just showing you how to work this. So say suppose Q is given as Q naught. In our case, you're given Q as Q naught, you can basically take Q naught minus under root K is equal to root L. L is equal to Q naught minus root K whole square. Then cost is W into L plus R into K. Actually, you should substitute it the other way down because we're solving for L. You understood why I did it, flipped it? Because we want to solve for L. So let's substitute for K instead of L. Right now you have this in terms of whole thing in terms of L, but now you want to minimize this over L, and this is the expression. Right now, of course, you can do it this way. You can, if you want, you can plug in the values of Q and R, but you will still need to take dq by dl, set it to 0, blah, 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 and then solve for L. You can do it that way also. You can plug in the values of W, R, Q naught, but you will still need to solve this differential. It's slightly little bit messy, especially if it is a linear function, everything is a linear function, then it's no problem. It comes out to be the same. But if it is not a linear function, it usually is a little bit more messy. But this method works like a much simpler calculation. It's not that messy. Like I said, this identity is coming from cost minimization itself. It's there in the lecture. I mean, the whole mathematical proof of this thing, W by this whole thing, W by R is equal to MPL by MPK. This proof is there in the lecture. I don't think we have enough time to go over the whole proof again, which is why I've left out the proof. But if you still have a problem with it, we can discuss it in the next class. But hopefully you can just refer to the proof in the lecture, in the video class, the lecture video. Okay, so this is the alternative way, but the answer is, I mean, the answer should of course be the same, either way, whichever way you do it. So L is equal to 100 is the answer. Let's go back to our question. So we have the answer. So, okay, let me pause it here. Is there anybody who has not understood what we did? What was the, what was the philosophy? What was the method we just used for cost minimization? Any problems? This is the method you can use irrespective of the form of the production function, which is kind of why this method is usually the more popular or the more recommended one, because irrespective of what form your production function is in, this method is a bit simpler, because when we take the ratio of MPL and MPK, whole lot of things get cancelled out, and the power and all, the exponent powers also simplify a lot usually. So it becomes like a lot more workable than um, than taking one and substituting the value into the other and all that kind of stuff. So that is why we do it this way. So the usual thing, if you're taking the cost minimization problem, we will always take MRTS is equal to W by R is equal to MPL by MPK. And in all of these, I mean, unless you have a cost function given to you already. So in all of these cases, you're given only R and W, right? You're not given a separate cost function. So obviously there are only two inputs, K and L. So the cost function becomes R into K plus W into L. So your cost function is a linear cost function, and you have a simple production function, the production function can take any form. But this, you can say, this family of problems in which you're given R and W and a production function, this method works. Otherwise, if you're given, I mean, hopefully, I don't think you will be given that kind of a question, but if you are given a separate cost function, then you go back to the basics and then you solve it in whichever way you like. You have 2 3 ways of solving it. But in this family of problems where we have taken the K and L, only two inputs, and we know the price of both the inputs, R and W are basically price of both the inputs, right? So in this whole thing, the method I just used is kind of sufficient for most type of problems. Okay, let's go to question 6. So which costs are fixed even in the long run? This is a not really very long question. I mean, you don't have to solve anything. So we basically kind of discussed this. Okay, one person has answered. Others? Okay, two people. Nobody else? Okay, so let me give you an example. Okay. So let's take an example. Say, suppose you are a business owner and your cost is, say, suppose some value AQ plus B, where B is your rent per month. Okay, B is AQ is just as your quantity of output increases, your cost is increasing with Q, whereas B is rent in per year or per month, whatever you want to take it. Right now, in this is the short run, you can say. I mean, I'm giving you just a very general cost function. So in the short run, say suppose this is what the function is following, which means that from one period to the next period, you have to pay that rent B, whether you're making any profit in that particular year or not. Let's say 1 year is one run or one period of the short run, right? So now, say suppose you're manufacturing something, you're manufacturing pencil boxes. Okay, now you have to, whether you're making any profit on your product or not, your costs may be very high or very low with change in quantity of your output, but the rent you're paying for that particular housing or that particular factory or warehouse, you still have to pay that rent, right? And that rent is not varying with the quantity. So that is your fixed cost in the short run. But in the long run, what can you do? If you want to shut down the business, you can shut down the business, right? Or what you can do is that in the long run, you can change it. You can, instead of using a big warehouse where you have to pay a very high rent B, you pay some other value, which is, some other value C, which is much lesser than B. Or you can just, decide that, okay, this rent is too much and I'm not making that much profit on my business anyway. So I'll just decide to work out of my own basement or my own garage instead of renting out a warehouse. So what you do, you take your whole setup and maybe you sell off some things or whatever else you do, you shift to your garage and you pay no rent. You're still manufacturing. So your B becomes zero in the long run. You don't have to pay any rent. You still have AQ. And again, it may not be A, it may be some other value, AQ, some other factor. You may have found some way to reduce costs or something, better production process, reduce labor, blah blah, whatever else it may be. So you have changed some cost. So what I'm trying to explain is that the fixed costs can also be changed in the long run. They are fixed in the short run. In the long run, everything can vary. In the long run, why? Because in the long run, your capital itself is varying, right? In the short run, you have usually the fixed costs you have in the short run are from the capital being fixed. You cannot vary the capital. You don't have any power to change the value of capital, or like say suppose this is the rent I'm paying per year. You can say that it's sort of like capital, right? Instead of rent on a warehouse space, this could just be rent on machinery. So instead of that, say suppose in the long run I decide to do away with the machinery and I do everything handmade. I just use labor and I give them daily wages. So it is not exactly you know fixed. I give them based on per unit of output. So, I mean, I'm giving you a whole lot of different examples of how these things can work out, and these are very real examples. This is nothing. I'm not telling you hypothetical examples. This is how a lot of businesses work. So, the whole purpose of this question is to explain that the fixed costs we're talking about are usually fixed in the short run. In the long run, even fixed costs can vary. So, they are not always fixed. Okay, so let's go back to the question. What did the question say? What costs are fixed even in the long run? So fixed costs are fixed in the short run, not necessarily in the long run. Variable costs are varying always. So obviously variable costs will not remain fixed. Some costs are the only costs you cannot recover because that is money which is out of your hands. Like I was giving the example of that forklift. Now in that forklift, after 3 years, you cannot sell it. You cannot do anything about it, whether you want to keep it or throw it or whatever else you may want to do. You cannot recover the cost which you spent on that forklift or any other machinery or anything else, basically, or like cost of education, for example. No matter what you do, whether you decide to work as an engineer or a doctor or whatever, or do you do something else, whatever amount you have already spent in your education, you cannot recover it. So some costs are the only costs which remain fixed because you cannot do anything about it. You don't have any other alternative. Marginal costs are anyways varying. I mean, it's not in some case they are not varying, but that is a special case. That generally there's no reason for it to remain fixed. Similarly, total cost has a variable cost component, so total cost is also varying in the long run. So I hope this answers the question.
Ma'am, but isn't it the sunk cost changes?
Changes in what way?
Like we discussed in earlier question, the sunk cost will be whatever cost, the opportunity cost, if it is available. Let's say, like the forklift example we took. First year we could sell it for 25, second year 10K, third year we couldn't sell it. So isn't it changing every
But
time?
that is we're talking about from one period to another. In the long run, that is after your 3 years, right? Sunk cost is actually the example I took. I just gave you that example to help you understand what it means. But in the real life, what we're talking about is in the long run, first of all, right? It's in the long run. In the long run, some cost is gone. So you should look at,
Got,
even if you want to take the forklift example, that is like beyond 5 years.
got it, ma'am. Got it. Thank you.
Yeah. And I gave a hypothetical example just to explain, the difference between opportunity cost and sunk cost. But usually that is not going to be the case. But it's not wrong. But what we're talking about is what remains fixed in the long run. In the long run, sunk cost is going to be more or less fixed. Not more or less, it will remain fixed. Okay, so let's go to the next question. Now, in this case, this function, this is the function given for the firm production function, minimum of AK, comma BL, where A is greater than 0 and B is greater than 0. Right? Basically, they're all positive quantities. That's all we're trying to say. The rental rate is R, wages are W as usual. So what we want to know is what is the cost function of this firm. So I'll just give you a few minutes to think it through, to solve it, and then I'll solve it in class. Has anybody solved it? Should I give you more time or should I solve it? Okay. All right. Let's go to the next question. Let me open the question. Yes. So you're given that the production function is of the form Q is equal to minimum of AK, comma BL, A, comma B greater than 0. So now, first of all, the most general form of cost function is what? Cost is equal to WL plus RK. This is anyways true, irrespective of whatever else may or may not be true. Right, just neatly. Okay, now what type of function is this? That is the most important thing to understand in these, you can say, this family of problems. The production function is minimum of AK comma BL, meaning what? That K and L are perfect complements. If you have K is equal to 10,000 but L is equal to 0, Q is equal to 0, right? Is that clear? If K is equal to 10,000, L is equal to 1, what do you have? Q is equal to B. First, let's understand the production function. If say K is equal to, I'm exaggerating by saying 10,000, let's just say 100, and L is equal to say 1. Okay, we don't know the values of A and B. For simplicity, let's assume A is equal to B is equal to 1. If then Q is equal to 1, right? Why? Because it is the minimum of the two values. Now, this is if A is equal to B is equal to 1. But if that is not true, if A is not equal to B, then Q is equal to 100B if 100B is less than A, is equal to A if 100B is greater than A. Okay, let me write this a little bit better. This is how you normally write it. So, did you understand what I just did? Q is the minimum of the two values, which is AK. Oh, sorry, I took the values opposite. Sorry. Okay, this will change. Yeah. So you are comparing between AK and BL. Now say suppose K is equal to 100, L is equal to 1. All I'm trying to tell you is that say suppose one factor is very huge, 100, and L is equal to 1, very small. Then you will compare 100A and 1B, 1 into B, right? Now out of that, it is equal to 100A if 100A is less than B, and it is equal to B if 100A is greater than B, meaning it's just simpler to understand if A and B is equal to 1. That's why I take it as that out of these two quantities, AK and BL, whichever is the lowest, only that much you can produce. Whatever else may be extra is just going to go waste. Say suppose we take the case of A equal to B equal to 1. In this particular case, if K is 100 and L is equal to 1, Q is equal to 1, right? Which means only one unit of K is used, right? 99 goes waste because only one can be used. You will use both K and L in equal proportion, only then you can work. A simple way to think of it is say suppose K or capital is a computer and L is labor, or you can say maybe an engineer or technician or whatever. Now if you have hired two technicians but there is only one computer, there's nothing for that second technician to do, right? There is only one computer and only one person can work on that computer. So your output is still going to be one unit, whatever unit you want to define that as. Similarly, if you have like say 5 computers, but you have only one engineer, that one engineer can use only one computer at a time. One engineer, assuming that he's not some super engineer or that kind of a hyper engineer, assuming that to be true, one engineer can use only one computer at a time. He cannot use 5 computers. So those 4 computers are going waste. He's using only one at one time, right? So this is like a simple example to visualize and understand this kind of a function where you have complementary inputs in the production function. So in this case, I'm taking 1 and 1, but it could be in some proportion, A and B proportion. Now, when we talk about cost minimization, I think actually Professor Vimal has discussed this briefly in the class. So for cost minimization, we need both to be equal in the cost minimization scenario because we don't want any wastage. What is it? AK, AK and BL. AK is equal to BL. So this is the basic condition which you need to kind of derive from the function which is given to you. Cost minimization is AK is equal to BL. Okay, so this is one equation, you can say one relation between between K and L. Now from here it is simple. Cost is what? W into L and K into R. Is that so? Now say suppose we have taken Q as constant, right? Now K is equal to BL. Now say suppose we take Q as fixed for a fixed quantity, right? That's what the question is asking, I think. Yeah, so it's not saying it explicitly, but when it is asking you for the cost function, you can sort of assume that q is constant because you're expressing it in terms of q. So when you're expressing it in terms of q, it means we're taking q as constant. So what we mean is q is equal to ak is equal to bl. Now from here, basically you get k is equal to q by a, l is equal to q by b. Now you take these values, you substitute it back into the cost function. Cost function is w into l. W into l is, sorry, let's just plug in the value q by b. Oh, I think I have taken a and b maybe as opposite. No, okay, no, I have taken it correct. Yeah, plus r into q by a. Isn't that so? All I've done is substitute the values of k and l into the original cost function. This was the cost function, wl plus rk. Now l is q by b. This q is looking a bit funny. Let's write it again. Yeah, so q by b, w into q by b plus r into q by a. You take q common, get w by b plus r by a into q. So this is what your cost function comes out to be. When you say cost function, we mean in terms of quantity. Now, in the same thing, if they give you some quantity and some values of W, R, A, B, you can find out the cost, right? So, for example, in this case, they have not given anything, they've just given you in the most general terms. But if you are given the values of W, R, A, B, and the quantity Q, then you can find the cost, right? You don't need to, I mean, you can, of course, calculate the value of K and L also, but just the fact that you have the cost function, like how we write it, cost function in terms of W, R, and Q is equal to this. And this is just notation where we are saying we are expressing cost in terms of the prices and the quantity. Okay, now again, we have one more question left, which is a very similar question with slightly little bit more complex production function. Now, following the same method which we just used, right? We used a similar method in this question and the question we did earlier, the one in which this question, we solved this question and we solved this question using very similar methodology. So using both of those, let's try to attempt question number 8. So we don't have too much time left, but I'll give you 2 minutes to think it through and see if you can solve it. And then we will solve it. So you're asking we are getting AK is equal to BL because we're considering the kinks on the L-shaped isochronds which intersect cost line in case of perfect complements. I'm not sure I understood your question, but I think you are right. I'm not sure. I mean, I'm not sure I understood the language of your question or exactly what you are referring to. But what we're trying to say is that we're taking that point at which, you get it's an L-shaped thing. Only at that point of intersection on that curve, you have AK is equal to BL. And at that point, neither labor nor capital are getting wasted, basically, which is what we want. And that is the point which will kind of touch the what do we call it? Isochron. Is that making sense? See, all other points are going to intersect it, right? If you take any other point on that L-shaped thing, it is going to be intersecting or cutting through the isochron. Only at that point where AK is equal to BL, that point, the corner of the L, only at that point when that touches the isochron, it is actually AK is equal to BL and not intersecting it, which is why it is satisfying all the equations, the equation of the isoquant and the equation of AK equal to BL. I hope I've answered you. Okay, let's solve this. Okay, I think two people have been able to solve it, which is good. Let's go over it. So that means hopefully you have understood the method. Okay, let me open the question here. So question is Q is equal to L to the power of rho plus K to the power of rho, whole thing to the power of 1 by rho. Right now, what we want to do is just to summarize what we want to do. What we will do first is MRTS is equal to W by R is equal to MPL by MPK, isn't it? This is what we just discussed. And then, I mean, let's take one step at a time, and then we will plug in whatever values are given and we will see where that leads us. So first, let's solve for MPL and MPK. PL, sorry, not D, del Q by del L. Now, Just give me a moment, please. Okay, you have L to the power of rho minus 1 upon, let's say, L to the power of rho plus K to the power of rho, whole thing 1 by rho minus 1. This is correct? I think so. Or no, it will not be upon. This is the part where it gets kind of tricky. You can just say, let me just stare at the function. This whole thing to the power of 1 by rho minus 1. I know, I'm sorry, this is a bit tricky. Hopefully, you guys have it better sorted out than me. Let's restart. This is a question of differentiating x to the power of a plus, say, z to the power of b whole to the power of c, let's say. Right, so del, say suppose this is y, del y by del x is equal to x to the power of a minus 1. And this whole function to the power of to the power a plus z to the power of b c minus 1. Is that correct? Or did I make a mistake? I'm just getting slightly confused. Yeah, no, I think what I did earlier was correct. Delete this part. I'm really sorry, but I get a little bit zapped out sometimes. So I think what I had earlier was correct. Let's delete this part. I was just trying to work out the differential. Hang on, what was it? L to the power of rho minus 1 and to the power of 4 by 5. So suppose this is 1 by 5. I'm just figuring out, taking some values and then solving it. Yeah, so this is upon L to the power of rho plus K to the power of rho whole to the power of 1 by rho minus 1. Similarly, MPK is equal to del Q by del K to the power of rho minus 1. Again, L to the power of rho plus K to the power of rho whole thing upon 1 by rho minus 1. So now the denominator is anyways going to get cancelled out, but still I didn't want to kind of leave that. Okay. This comes out to be L by K to the power of rho minus 1. Okay, and we have W and R. MRTS is equal to W by R. So notice that in all of these calculations, we have removed the minus sign everywhere because it eventually gets cancelled out anyway. So, we've kind of removed the minus sign everywhere anyway. But technically, the minus sign is going to be there. It is just that we know that it is minus MPL by MPK and is minus W by R. So we are just basically taking minus minus out. Okay, so rho we are given as what? I didn't write the values, right? Okay, let's write the values here. What is given? Yeah, rho is given as half. W is equal to R is equal to 1 and Q is equal to 4. So let's solve this. W by R is equal to 1. L by K into half minus 1 is minus half. So basically you can just flip it. It doesn't, in this particular case, it doesn't actually matter. It means K by L to the power of half is equal to 1. Therefore, K is equal to L. This is basically the final answer which we get. Now, if you simplify the production function, Q is equal to what we are given is rho is equal to half. So we can just put K to the power of half plus K to the power of half whole thing to the power of 1 by 1 half is equal to 2. Okay, so this becomes 2 root k whole square. So this becomes 4, isn't it? Q is given as 4. Therefore, k is equal to L is equal to 1. So it's not, it didn't turn out to be that complex in the end because of the values that were um, given. Yeah, I mean, you can substitute as rho is equal to half in the beginning, it makes it simpler, but I just wanted to solve it for the general case to, give you an example of how to address these type of problems. And then you can substitute the values. Yes, I mean, a lot of times it does, if you're in an exam or something, you don't have time to go through all this, workout, you can just take it as half in the beginning. It makes the whole thing much simpler because just dealing with the arbitrary value in exponent generally makes the whole thing look a lot more complex. Anyway, I wanted to solve it for the general case since this is a tutorial class. So this is what your answer comes out to be. Hopefully it is clear to everybody. And this time I think I have just the right number of questions for the class. So I guess that completes it. You're saying question 7 of assignment 8. So 1 minute, I forgot to know what the question 7 was. Yeah, so in this case, I want you to actually calculate it yourself. I mean, I just did a whole lot of questions where we calculated marginal product for one factor and the other factor. Now, okay, let me see question 7 of. So you're given f of x1, x2 is equal to c x1 to the power of a. This is basically the same thing, similar thing what we were doing, Cobb-Douglas. So del f by del x1, right? Now this is what they're asking you is A, B, C are given as positive. Okay. And what they're asking you, wait a minute, question is, yeah. Marginal, is there a decreasing marginal product for factor 1? Okay, this thing A is, yeah. So this is your marginal product. I'm putting 1 as subscript for good one, x1. Now we are talking about marginal product itself being increasing or decreasing. So say suppose this is g of x1 comma x2. Okay. So when we want to know if some function is increasing or decreasing, we take its first order derivative. So we take, say suppose g prime x1 comma x2 with respect to factor 1. That means del mp1 by del x1. You getting me? I'm taking a first order derivative of the marginal product of factor 1. This gives you C a into a minus 1 into x1 a minus 2 into x2 b. Now we want to know whether this quantity is going to be positive or negative. We already know C and A are positive. Now if you want it to be decreasing, for to be decreasing, mp1 prime should be less than 0. Right? For a decreasing function, its first order derivative is less than 0. Therefore, C a minus 1, x1, a minus 2, x2, b is should be less than 0. Now, in all of this is positive, this is positive, this is positive, this is positive, because all the inputs are positive, so any exponent of the input will also be positive. Only question is about this quantity. So there is only one scope for this to be decreasing. If a minus 1 is less than 0, mp1 is decreasing. Therefore, a is less than 1. No, I mean, C and B greater than 0 is already given to you. So there is not really anything new there. This is already given in the questions. There's not much to think over here. The new condition you get is basically A is less than 1. This is the new condition which you derive for that. You have left. Okay, I mean, if you have left, that's fine. I was all solving the question for you only. But uh, anyway, so that is the solution. That is the answer. And I hope it's clear. It's just maths actually. There's nothing much to riddle over here. It's just simple maths. So whenever you're asked whether some function is increasing or decreasing, the simple thing is just take its first order derivative if it is positive, or if you're asked a condition for which some function is increasing or decreasing, then take its first order derivative and set that condition as equal to or greater than or less than 0.
Thank you, ma'am. I got it, ma'am. I had gone basically confused with a minus 2. I got it now. That won't matter because that will just go to the denominator, ma'am.
Yeah, it's, I mean, a positive quantity raised to any exponent is still positive. So,
Yes, ma'am.
yeah, it's the coefficient which will decide the sign of the
Yes,
function.
ma'am. Yes, ma'am. Yes, ma'am. Thank you,
Okay,
ma'am.
all right. So I will upload the today's slides and today's class notes to the same shared folder. And I think we can end the class here. There are no further questions. So thank you everyone for joining. I'll see you next week.